Hello and welcome to this latest edition of MCCIA's AI in Action episode. Today, we are fortunate to have a very special guest all the way from Silicon Valley, US, Professor Ashwin Rao. I'll call him Ashwin because he's my batchmate from IIT. And he's done some really interesting things in different industries, and we'll be learning about that in today's discussion. So we have about 45, 50 minutes, and it's going to be very fascinating. So let me quickly introduce Ashwin to you, and then we'll directly get into our discussions. So Ashwin, I'm going to call him Ashwin. Ashwin currently leads Target's global artificial intelligence team, responsible for products involving demand forecasting, inventory planning and control, price optimization, personalized recommendations, and others. He is also an adjunct professor in applied mathematics at Stanford University, where along with research and teaching and reinforcement learning, he is also directing the mathematical and computational finance program. So we have an industry guru, we have an industry veteran, and we have a professor at one of the top universities in the world. Prior to this, Ashwin has done an interesting startup in the recruiting space. And before that, he spent over a decade in the quantitative finance, algorithmic trading area at some top names in the industry, namely Morgan Stanley and Goldman Sachs. So we will briefly talk about that as well. So there's plenty of areas to talk about today in terms of AI in action. We are going to talk about retail and supply chain. We're also going to talk about finance and some other areas as well. So let's get right to it since we have a lot of things to cover, right? Before we get to specific application areas, it will be very interesting to hear firsthand from Ashwin about his fascinating journey all the way going back to IIT. So Ashwin, can you briefly talk about your journey so far, which included moving back to India briefly, then moving back, then getting into academia? You've really touched upon so many different areas. So it would be very interesting to hear about it from you.
Yeah, Amit, firstly, thanks for having me here today. It's always invigorating talking to you. You and I went to IIT Bombay together, so I'll start talking about my journey from there. I started as a computer scientist, but to be very honest, at that time, I didn't quite like the courses in our CS&E program so much. And I didn't do well with my grades either, but I got quite influenced with some of the professors in the space of theoretical CS. And I realized I wanted to be in the part of CS that has mathematical foundations. So that sort of was my first step into a new area. It led me to a PhD in the intersection of algorithms and abstract algebra. And my thesis was in algebraic geometry. But again, a little bit of a twist in my life because I realized this math is really hard towards the end of my PhD. And honestly, a bit beyond my reach if I wanted to remain as an academic. So I looked for an escape after my PhD. And so back in 98, the problem was nobody wanted to hire you in the tech industry if you were a theoretician. So I went to Wall Street, where there was a lot of appetite to hire people from math and physics backgrounds.
Mm-hmm.
And so I worked at Goldman Sachs, Morgan Stanley for 14 years and quite enjoyed the work there. But again, another twist, working on the trading floor for more than a decade burnt me out a little bit. So I started my own company in 2012 to do something fresh. And then after 3 years, we were acquired. And then I took a year off work and just sat at home, but that wasn't working for me either. I was going a little crazy. And so I joined Target, the retail company in the US in 2016, because I wanted to learn about a new business domain. And that has sort of been my interest always, getting into areas because you have a steep learning curve. And then 2 years ago, Stanford offered me a job. So this is my second job as an adjunct professor in applied math. And so the past 2 years, Amit, have been very heavy for me in terms of load. It's been super busy, but the work has been really interesting because AI has taken off, and there are so many interesting problems now both in my academic world and in my industry world. So that's sort of my overview on it.
I think it's really fascinating, and some of them we may touch upon as we move around. But let's get right to, you mentioned Target. Now, for those of you who don't know here, Target is one of the largest retailer in the US, one of the largest retailer in the world. So it has its own unique set of challenges. But we won't specifically talk about the company, but given Ashwin's experience in retail and supply chains associated with it, we're going to delve right into the specific application areas of AI and data sciences more broadly into this space. I have briefly worked in this area, but nearly 2 decades back. And of course, that time the technologies were quite different in the way we used to look at demand forecasting, inventory planning, inventory management, and other functions. Things have changed a lot, and I haven't been in touch with this space actively over the last decade. So it'll be very fascinating to hear from Ashwin how AI and the latest data sciences technologies are being used to solve some of these problems. Maybe we can start with demand forecasting, but I do want to touch upon at least 3, 4 of these core functions in supply chain for retail.
Yeah, again, I'll provide a bit of a historical perspective to the modern situation. So Amit, as you very well know, having been in the space, a retail business is a very vast and complex business. And there are several applications of mathematical modeling and algorithms development in various aspects of retail business. So in traditional brick and mortar retail, demand, I would say 3 things have been always important: demand forecasting, inventory planning, and price decisioning. These are key problems so that you can run a robust business and you can serve your customers well. So 20 years ago, all of this was done pretty manually, and there would be dedicated staff at each retail store that would come up with local demand forecasts. And people had a lot of intelligence about their customers. And so they would use spreadsheets and then make decisions on ordering inventory in a fairly reactive manner. Meaning, if I did a lot of sales today, I would place large orders with my supplier tonight. Mm-hmm. And price decisions were made in an ad hoc and instinctive manner. If I'm not seeing a lot of traffic, I want to do a promotion and put out a big ad in the newspaper. The traditional approaches were not grounded in optimization, although you very well know the literature in OR is full of advanced math to solve these problems ever since the 1950s. Now, many retailers have recently jumped on the data science bandwagon and are starting to employ machine learning to solve these problems. To give our viewers a sense of what's involved, demand forecasting is a statistical estimation problem, and one can actually tap into some of the recently developed techniques from deep learning to create good demand estimates. Inventory and pricing are classical stochastic control problems, and so reinforcement learning is a good fit to solve those problems. However, my advice to people, data scientists in that space, is that you don't need to start with machine learning. Traditional regression techniques often work just fine. Likewise, instead of reinforcement learning, simple dynamic programming algorithms or simpler approaches like new spender formula, Amit, which will bring back happy memories for you, those will often suffice. The key is to learn the business details really well and to capture those in one's mathematical model. And I think good old-fashioned mathematics and CS often suffice. And then once you've got some traction, then you can move on to the more modern AI algorithms.
I think that's an important point. I mean, many times, and this is true generally for technology in computer science and even in other areas of technology, which is you often don't need a big, a cannon to shoot an ant or something like that, right? I mean, sometimes good old simple techniques just work fine. And you mentioned regression, basic regression for demand forecasting, and that's something that I am familiar with. About 20 years back, that's essentially what we were using. But and without getting too much into the technical details of it, how specifically deep learning being used in this area, where say regression was being used, and especially when you're at the cutting edge of forecasting, right? When you're dealing with one is scale. Obviously, you're dealing with thousands of stores and millions of SKUs. SKUs are stock keeping units of products. We call them as SKUs in the retail industry. But so scale is one complexity. But just the number of dynamic variables has changed a lot, especially in the last 10 years, right? So that's one value where deep learning. So if you can walk us briefly through, what has changed, deep learning versus regression, uh, without getting too technical. I think that's a challenge because you don't want to
Yeah.
get into mathematics of it.
Yeah. Look, like I said, I think regressions work well if your data set is not too vast and diverse. The traditional statistics doesn't scale up very properly. And what I would say is with deep learning, you want to use deep learning when you've collected a lot of potential explanatory variables. So as you know, for demand forecast or to predict stock prices, there are thousands of potential factors. So you can put the kitchen sink of factors into your
Uh-huh.
model, right? And the deep learning algorithms, internally, they figure out the correlations between these factors and they will fit it. So the problem is it will be a little bit opaque. You may not understand exactly what it has done, but that's where deep learning shines when you have thousands of factors. Where you've got 5 or 10 factors, I think the statistical methods will work pretty well.
I think that's a very important point because I think we have had this discussion in the past as well, where deep learning explaining the results is difficult, but sometimes when you're dealing with so many different variables, you can't just go into a conventional model. And I think that's clearly where deep learning can make a difference. Let's talk about some of the other areas. You mentioned inventory planning as well. Now there we were used to again, the traditional methods were more to do with sometimes just basic heuristics, sometimes some amount of intelligence. Sometimes for long-term decisions, we have also seen linear programming being used. But how's that space change? Because again, replenishment and inventory planning is basically keeping the right material at the right place, right? And that could be the store, or it could be one level behind, which is typically the warehouses or the distribution centers.
Yeah. So this problem, inventory control, is a classic control problem. So control means that it's a sequential decisioning problem that every day you look at your inventory, you estimate what demand you might get over the next few days, and it's uncertain demand, right? Amit, as you know, like 2 people may buy your product
Right.
or 10 people may buy your product. So you've got significant uncertainty, but you have an estimate of the uncertainty and you look at how much inventory you have and you decide precisely how much you want to order. If you order too much, what happens is you may flood your store with too much inventory and things may just sit around. There's a risk of that. But if you order too little, you have empty shelves. So to find that exact balance between
Right.
stockouts and holding cost. So that decision variable is how much to order and when to order, and we optimize that. So we call that stochastic control, and the reinforcement learning is just one of the algorithms, one of the class of algorithms that helps you solve stochastic control by studying tons of data of historical behavior of people's
Right, right.
buying
The
patterns.
third area that you also briefly mentioned early on is about pricing and making merchandising decisions, right? How's that space? How's deep learning and AI being used in that space?
Yeah. So again, one doesn't need to go to the full-blown, deep learning and AI. This is also a control problem, as in think about clearance pricing. So you got like 8 weeks left to end of season, and you got a ton of inventory sitting in your store. So you have to cut your prices.
Correct.
But if you cut it too early or cut it too much, what can happen is you can have a lot of sales and you may run out of inventory before end of season when customers are very happy, right? They are unhappy because they see your empty shelves. But if you cut it too little or delay cutting prices, you may not sell enough, and then at the end of season you got tons of inventory sitting around. So that precision of how much to cut, when to cut, is also a stochastic control. And so again, reinforcement learning is in play for this. Although the traditional dynamic programming type methods actually work pretty well.
I think that's interesting to hear that traditional methods still work, and I think there are two schools of thought, right? I mean, there are people that talk about how AI is going to completely change everything, and then there are things, and there are some people who are going to say that things are going to gradually change, but not. But that's something that I'm going to ask you at the end. But to put your future viewing glass and tell me what's going to happen 10, 20 years from now. But before we get there, one other point on supply chain and retail before we move to some of the other interesting domains that we want to talk about. Given all the new toolkits that you have in AI deep learning, as well as some of the hardware changes that have happened, obviously, hardware revolution has been big to support some of these algorithms, especially in the last 5 to 10 years. How has this space changed compared to tradition? I mean, you mentioned that in some areas we're still using the traditional algorithms, but clearly there are things that have changed for all kinds of retailers, big and small. What kind of and ultimately all of this boils down to business metrics, right? How has this transformed some of the business metrics in terms of the inventory, in terms of the pricing, in terms of bottom line?
So Amit, it's about precision. I think, as you know, retail industry had become more and more competitive over the last couple of decades. So being very precise with these things, forecasting, inventory, pricing, gives you a significant advantage in your business. So that is what has driven the push to machine learning, because it gives you great precision. Hardware. Now, you talked about hardware and data. These are the two things that have actually facilitated machine learning. So the retail industry has been, over the last couple of decades, gotten better and better at collecting data. So not all companies were good at leveraging the data, but they always collected, they stored it, they organized it. So data engineering is a big area in retail. Although people like to talk about more data science and AI, data engineering is a big thing. And then, hardware has become very cheap, so you can actually go in that direction. So what all this buys you is more efficiency in your business, better understanding of your customers. That is the area which has also been improving a lot because of our digital business. Bear in mind that in stores business, you don't get to see your customers that much. You don't collect their interests and what they like and all that stuff, right? But we also have a digital business at retail, as do many retailers.
Right.
So
I think hybrid model is becoming very common now for most traditional retailers.
Yes. So for somebody who's a traditional brick and mortar business, if they also have a .com business, they get to see what their customers are searching for. They get to see what they're clicking, what they're buying, when they buy, and all that. And that is all data mining. And this is also an area. Digital business is an area where machine learning comes into play big time, because you can then build good recommendation systems. So companies like Netflix have been, or now YouTube, have been doing recommendations for a very long time. Right. So there's no reason why retailers should not be doing the same.
Yeah, I think that's a big area by itself, the whole recommendation piece. But we may come to that towards the end. I want to talk about your other core area where you have spent over a decade, and which is finance. And I think that's an area of interest for many people, because unlike some of the complex processes in the retail and other industries, everyone understands, or at least they think they understand, stock trading, right? And there has been this crazy fascination about algorithmic trading in the minds of many people for over 2 decades now. I mean, there was this whole wave during the 2008 crisis, and then the discussion has been on and off going on, I guess, for a long time. And you're a veteran of this industry, so there's lots to cover here as well. But can you talk about the basics of deep learning, or actually let's not start with deep learning, but just data sciences in this industry?
Yeah, again, let me give you a bit of a historical perspective to landing to where we are today. So, Amit, as you know, finance has been infiltrated with plenty of mathematics for several decades now. Back in the 1980s, this started with Wall Street hiring math and physics people, and they did a lot of stochastic calculus, partial differential equations for derivatives pricing. Then you had this wave of algorithmic trading that came in the early 2000s, and then statistical modeling plus some of the computer engineering became really important. Then hedge funds got into the game and took it to a completely different level. Now, in the last 5 years or so, the finance industry has been trying to replace some of the traditional techniques with machine learning. So now there is indeed a lot of machine learning work going on to predict, say, movements of financial assets, to place optimal orders on a trading book for optimal asset allocation, and also in derivatives pricing. And reinforcement learning, which is a branch of machine learning, has become particularly hot in this space. So this is why I created the course at Stanford dedicated to the topic of RL for finance. And having said all this, Amit, making machine learning work in practice in actual financial markets has actually proven to be challenging. This is because we are still in the early stages of this journey in machine learning in general, but also in terms of applying it to financial markets in particular, there are a lot of nuances, and so there are frictions and things don't quite work. So we're still in experimental phases. You don't see machine learning deployed all over the place yet. We are sort of we're in a transitionary phase right now. But I think the future of the intersection of AI and financial applications is really promising. And one more thing, Amit, I want to point out that beyond financial trading, there's a lot of potential for using AI in personal finance. Mm-hmm. I think in about 5 to 10 years, we will have apps that will make all our financial decisions, like what credit card gives us the best rewards, what kind of mortgage loans to get, how to save optimally for retirement, how to balance risk and reward in one's personal trading portfolios. So it's coming very soon.
Yeah, I think there's a lot of different areas in here. I wanted to ask specifically about the algorithmic trading aspect as well. Now, what kind of techniques have been used, say, about a decade or so back when you were active in the industry, and have those changed over the last decade, or we're still pretty much doing something similar? Because a lot of high frequency trading does happen, and I guess the amount is just increasing every year.
So Amit, there's been a transition to more precise trading. The same pattern that I was describing in retail, right? As margins are getting squeezed, there's more competition. So 20 years ago, there were a lot of handcrafted rules by traders. So even before we brought all the stats and machine learning, the way humans traded, mm-hmm. You try to just program those things. Like you would say, if this is what the stock does, I want to buy. Mm-hmm. And people actually did reasonably well, even with something so simple. And so heuristics and human programmed decisions were there for a long time. And then that transitioned over to, I would say, more traditional statistical methods, like regressions, and the rich history of statistics was tapped into. And once you get into the statistics space, I call machine learning statistics on steroids. So that was always the natural transition. From statistics, you then stepped into the world of ML. But ML is very opaque, and I think Wall Street gets a little bit uncomfortable with opaqueness, right? So the clarity of what is actually happening inside the algorithm is really important. So there's also an area of explainable AI that is emerging right now, which is, I think, going to help Wall Street adopt machine learning a little bit faster. But that journey from statistics to ML is currently on.
Interesting that you mentioned explainable AI, because that's a common theme that we have talked about, as well as I have talked to some of our other guests. And that's a challenge, whether it's manufacturing, whether it's retail, whether it's stock trading. The practitioners want to understand what is happening. But on the other hand, we keep talking about this as a black box. So there is some implicit assumption that we may not explain everything. Yeah. And where is that field heading in your view? And I think this has implications everywhere and a lot of legal implications, especially if you get into say self-driving cars and insurance processing. It's a bit of a digression from the points that I have, but I think it will be good if you can talk a little bit about explainable AI.
Yeah. So firstly, explanations for different types of people, Amit. Like I think firstly, it's very important for the scientists themselves to understand what's happening. Because if you take a self-driving car and it crashes, the scientists better quickly understand what happened and try to debug it and all that stuff, right? So that is the first thing. But question is, do you want explainable AI for like the masses? Like if you're driving a self-driving car and the car made like a sudden turn and you were a little bit scared, but you were fine, nothing happened. You're curious what happened right now. Why is that? Because you're still not comfortable with this technology. But if you fast forward 10 years where we might have self-driving cars all over the place, and imagine cars are driving in a very different manner compared to humans. You're not going to really ask a question like why did it do this? Like it just did something, it worked for me. I think that journey of getting comfortable with new technology, that may actually reduce the importance of explainable AI. But I think in the next 3 to 5 years, people want explainable AI because they're a little bit like uncomfortable or scared, perhaps.
I think it could also be a generation thing, right? I mean, the next generation will probably take some of these things for granted and not expect explanations for everything. But it sounds like it's a fairly non-trivial mathematical challenge to go in. Is there some research work? I would guess a lot of research work is going on in that area.
Yeah, there's now a buzz term for it. It's called XAI. It's a big, if you Google XAI, you'll see there's a lot of links that will show up. I think even many governments are sponsoring it. Many companies are looking at it. There's a few startups who have been working on XAI, just XAI, right? So I think it's a hot area. We in academia, Stanford, a lot of interest in it. Growing area. I think it also connects to some of the ethics and legalities of AI also. So I think there will be new departments emerging, which is not quite the technicals of AI, but some of the softer aspects of AI. And I think XAI will intersect with all that stuff.
So on that topic, one more digression, a digression of a digression, right? Your quick thoughts about GPT-3 and some of the most recent milestones that have been achieved.
Yeah, look, GPT-3 has been extremely impressive in certain things. And you've all seen the results on the internet. It's a different type of experience for a lot of developers because you don't have to fine tune the model that comes. The model understands your context. You just describe, this is the problem I want to tackle with GPT-3. You give it just 2 or 3 examples versus the previous models which came pre-trained. You had to do a lot of fine tuning to your data. So GPT-3 doesn't require that. So that's been a big game changer that somebody who barely knows machine learning can just take it and start using it. But Amit, again, we are in early stages of it. For every flashy article that is written about GPT-3, I have been trying it for the last couple of weeks, and there are a lot of problems in it as well. There's a lot of strange things it says. I think there are huge biases in our data which GPT-3 has picked up. It uses this common crawl database, right? So, it has racial biases, it has political biases, and it sometimes says things which are somewhat inappropriate, and I don't think it's fully cooked for mainstream consumption. And GPT-3 folks have actually said it, that people should only try it right now. They want to fix these bias problems, and we hope in 3 to 5 years, the next generation of this model will have overcome the biases.
That's good to hear. Let's talk briefly about your academic experience. I think that's something that I know you really enjoy. You briefly mentioned how you got into this area, but what are the kind of courses you're teaching, and how's that experience been?
Yeah, so my area is the intersection of machine learning and finance. So So my department has a long acronym. It stands for Applied Math. But within that, we have different programs. The program I lead is called Mathematical and Computational Finance. So that area, as I was explaining earlier, has mostly become like AI for finance. And so within AI, the area I do research in and the course I teach is reinforcement learning for finance. And reinforcement learning is one branch of machine learning. It's about optimal decisioning. So 2 years ago, when I joined Stanford, I created this new course, and it was a bit speculative. I was thinking about like where we could apply ML in finance. And I started looking at some of the problems we used to work on 20 years ago. And I looked at it from the lens of machine learning, and suddenly I realized like all of these problems can be um, conceptualized from a machine learning lens. And suddenly, like I came up with 5 important problems. So these problems are firstly, optimal asset allocation for portfolio optimization, a couple of problems in derivatives pricing and hedging, and then problems in high frequency trading. Like if you want to sell a large number of shares, how do you break it up and sell them in a sequence optimally? And then also optimal market making, like a dealer will have to show bids and asks. So how wide do they show it and when they show it? That control can be done with machine learning. So that's been my area.
And this is a graduate course or an undergraduate?
Yeah, Amit. So this is a master's program in mathematical finance.
Okay. Interesting. I think not many people can obviously go to Stanford, one of the best universities in the world, but we have quite a few people here in Pune, bulk of our audience, who will be who are working in the software industry and have done undergraduate, sometimes even masters in computer science here, and they want to get to the next level. And what would your advice be for them? In terms of online courses or other self-paced learning tools out there, or is there something radically different they should be doing in terms of projects? I think this will be very helpful.
Yeah. Look, Amit, I will say that my advice tends to be a little bit old-fashioned and boring. But I'll just say it, that to step into this field of AI, machine learning, all this stuff, people should over-invest in the foundational topics. Um, I think even we as educators sometimes lose track of the fact that there is so much deep foundations in these areas. We always talk about very advanced technologies. So I would advise for everybody, keep a learning track open for the new and advanced developments like GPT-3, but don't spend too much time on it. I would say spend 70% of your learning time focused on the fundamental mathematics and engineering that underpins AI. So what does that mean? That means one must invest in getting really good at things like linear algebra, probability theory, optimization, and then on the CS side, distributed computing, database systems, and most importantly, you should try to become a Python ninja. I think Python has become so important. I would in fact tell most mainstream data scientists, forget about all the Java and C++. The specialists can do it, but get really good at Python. And I would give this advice even to AI leaders, because if you want to understand this area really well, you have to be very hands-on. And what that means is getting into the foundations.
I think this is very valuable, and I think you are going to get a bunch of emails and other questions on this from some of our audience, because I think people will know how to get to reach you via your Stanford page. Now, we are coming towards the end. We have about 5 to 10 more minutes planned. Two or three things I wanted to quickly touch upon. Right. One is specifically, I had briefly talked about your interest in sports, and we do want to talk about cricket. But before that, there was this interesting film that I'm sure you must have seen in 2010 or 11 called Moneyball. And that did delve into using data science in modern sport, in various aspects of modern sport, whether it's selecting the right team, whether it's the kind of plays, the probabilistic distribution of your calls. Would really like to hear your views on that, and not just for baseball, but for all of professional sport.
Yeah, Amit, you probably know this. In the US, this is happening in many sports. In fact, some professors that I know are working on not baseball, basketball. Another person is working on football. NFL is investing big time in it. So this is very possible right now. I don't think you'll see great solutions by next year. But what is happening is you collect all this rich video data now, and you can process it. You have all these fine-grained decisions. So just coming to say IPL, for example, I guess a match is going on right now. Your algorithm may actually detect small details in a fielder, that if this fielder stands in this situation under pressure, that fielder is dropping the ball all the time. But this fielder is really good close in slip catching, even under pressure. It's very difficult for humans to understand all these details, right? But the machine learning algorithms will pick up all this stuff. It will understand for batsmen, how do they play it against left arm bowlers, right arm bowlers. It'll see all these subtleties. You can strategize to say after 10 overs, who should come on to bowl. When somebody is batting, you should come on to bowl. Dhoni's promoted himself up in the 2011 World Cup. That was Dhoni, but machine learning can actually take that whole idea to the next level, right? Because if you have a off-spinner bowling, you don't want a left-handed batsman to come in. But the algorithm might actually find there are some left-handed batsmen who do pretty well against off-spinners. And so this is where you're overcoming the human biases, that humans will just say every left-handed batsman is bad, but you just find like a couple of them are exceedingly good, so it's okay to send them. So this type of fine details, I think, will be very, very important in sports. And I think in cricket more than anything else, because you have such rich data in cricket, because something's happening all the time.
I think you already jumped onto cricket, so that's great. I think cricket is probably one of the most data-rich sports in terms of the amount of information we are tracking all the time. And the fact that you mentioned video is important, because you don't have to manually key in all this data, right? If you're actually physically tracking the movement of the fielder, you actually have the actual location of that fielder, and then the movement of the ball, and all of it is. So I think it's going to be fascinating a decade from now how some of these professional leagues in cricket and all sports are going to perform. But you've been a big fan of cricket all the way back to IIT days. Do you get any chance to play these days at Stanford?
No, I played a lot of league cricket until 2012.
Okay.
For a couple of decades, I was obsessed with it. I played every weekend in leagues in New York, LA, Mumbai. No, I just play tennis now. I think cricket requires, to be honest, cricket requires a much higher level of organization. Also, I think a much higher level of fitness to play T20 cricket. I think tennis is easier at my age now.
And I think that's I think we are revealing our age as well, right? So I think the last question that I'm asking pretty much every guest on this show is 2030, because 2025 is right here, right? 2030 or 2040. Where do you see AI at, and how is, more importantly, our world, both personal as well as the business world, changing because of AI?
Amit, I was hoping you wouldn't ask me this question, because I think whatever I say will likely be proven wrong. So look, in all seriousness, as you know, there's a lot of buzz around AI today. And particularly where I hang out in Palo Alto and Stanford, everyone is painting a science fiction world by 2030. I don't quite agree with the view that AI is going to autonomously solve the big problems in business and society by 2030. When I look at the most important decisions companies or governments are faced with, I think AI can only be a helper to people in making key decisions. I don't think it will be a fully autonomous solution by 2030. We should not get carried away by the enormous success of AI in three areas it has succeeded: natural language, vision, and games, which are all fairly well structured problems with very clean, reliable, and rich data. But if you look at physical problems like robotics, we are still at the stage of fairly basic tasks and nowhere close to having robots replace humans. So there is a lot of promise with techniques like these attention networks or reinforcement learning, and AI research is definitely progressing fast. But to be really blunt, Amit, there is a lot of hype associated with AI. We are at the stage of what I call augmented AI and not autonomous AI, which means AI should be looked at as a technology that will help humans do things better and faster rather than replace humans anytime soon. I think the power of AI in the next decade will come from an effective blend of human intelligence and machine intelligence. So my view is a minority view among AI academics, but that's perhaps because I am half academic, half practitioner, and I get to see the enormous challenges of getting AI to work reliably on the complicated edge cases in practice. It's very easy to build sorry, just to wrap up, it's very easy to build a cool toy application and get a PhD thesis for the work, but very different challenge to make things work in production, where many things can fall down.
Yeah, you mentioned three things, right? You mentioned games, you mentioned vision, and you mentioned natural language processing, right? Those are the easy areas, but I mean, you're right. There are a lot of tough challenges, even on the business side, and I'm focusing more on the business application side. And I think let's go back to where we started with, even in, let's say, in retail or in manufacturing, the kind of supply chain problems that are out there are still, I think, fairly non-trivial. And to solve them very easily by just throwing hardware at it is not going to. So I think I agree with you. I mean, I'm not. I'm definitely not in the sci-fi camp of AI changing everything. But it's great to hear from you, from someone who's, as you said, both a practitioner as well as an academic. And I think that's a rare combination, and we are very fortunate to have you here. I think I'll just wrap up. Ashwin, this has been an absolutely fascinating 45 minutes. We have a restriction on time, but we could have gone on and on. And of course, I don't want to take up a lot of your time as well. But we've touched upon so many interesting areas. Each of these could have been a separate conversation by itself, whether it's retail, whether it's finance, whether it's sports. We talked about cricket as well. And the list goes on. So I think I know you're very busy, but it would be great to be back sometime soon, few weeks, to talk about any of these areas in a little bit more detail. Today was more of a broad-based coverage of the entire gamut of things, right? So last question, since let's end on cricket, right? Who are you supporting this year on IPL?
Amit, I don't watch IPL actually. My sport is Test cricket, and I feel IPL hurts Test cricket. So I don't watch it. But look, I'm from Mumbai. When I see Mumbai win, even if I see it in the news, I feel very happy. So always Mumbai.
Good. So let's close on that. I know, by the way, I'll contradict you on that. I love all kind of cricket. I mean, I agree. Test cricket is a completely different. I call them two different sports. So Test cricket is a different sport. IPL is a different sport. So, but hey, thanks a lot, Ashwin, and hope to see you on this platform soon.
All right. Bye, Amit. Thanks.
Bye.
Nice talking.